Good morning, everyone. Welcome to our fourth Mesh IQ Tech Talk, Why Observability is so important for the modern integration mesh. Just to let you all know, this Tech Talk is the fourth in a series of Tech Talks that Mesh IQ will be presenting bi-weekly. Our presenters today are Jason Bloomberg and Albert Mavashev. Jason Bloomberg is founder and president of Intellyx. He is a leading IT industry analyst, author, keynote speaker, and a globally recognized expert on trends in enterprise technology and digital transformation. Albert Mavashev is Mesh IQ's CTO, expert in integration, middleware, application performance, streaming analytics, blockchain, observability, and decentralized computing. We will now get started, and I'll pass it over to you, Jason.
Thank you very much, Jessica. So to kick this off, it'd be great if we had a definition of mesh. I know some people on the call are familiar with the term, others are not, so that's probably a good place to start. So Al, if you would let us know what a mesh is, and we'll take it from there.
Sure. Thanks, Jessica. Thanks, Jason. So mesh, it's been actually kind of redefined a few times. So before, a commonly used term was middleware. However, today there's a lot. It's just a whole ecosystem of technologies that are interconnecting applications. So typically, what you have in the mesh is an ecosystem of different technologies that connect applications, business services, and other tools together, basically via digital ways or digital railways. So today, what typically falls into this mesh, into the definition of the mesh, it would be things like messaging middleware, it would be APIs, brokers, even things like application servers. And there's other actually elements that fit into this, like, for example, even managed file transfers, because actually, believe it or not, a lot of data movement is still done via good old, managed file transfers and FTP. But there's some others, even emerging things like blockchain, and that's because it interconnects all these things together. So I would look at just an ecosystem of tools and technologies, software and hardware, that connects applications and business services together.
Yeah, so you mentioned middleware, and that's an older term. I remember talking about middleware in the 2000s, and actually was part of the discussion in the 1990s. And even in the 1990s, one of my first positions at PNC Bank was part of the role was dealing with IBM's MQ product. It was called MQ
Right.
Series at the time, and then WebSphere MQ, and now I think it's IBM MQ unless they change its name again. So, and I know Mesh IQ, your history as Nastel started off focusing on the MQ product. So how much is that message queuing product or message queuing generally? How important is that to the mesh story, and sort of where have we gone since then? Right, there's a lot more to middleware than MQ, and there's a lot more to mesh than middleware.
Yeah, it's true. It's kind of evolved. And I remember, when MQ started, actually, usually investment banks would create their own kind of proprietary messaging platforms to connect all this together, and then a kind of MQ emerged. And there's a whole new generation of technologies that was followed by JMS, and now some of the newer types of technologies such as Kafka. And then you see actually Kafka is being adopted on many different levels, especially for high throughput types of applications. So you have different types of messaging and middleware deployed in different types of applications. And what kind of makes this space very interesting is because now it's a hybrid environment. So you have MQ, often coupled with technologies like Kafka, brokers, another set of middleware and other types of meshes, and they all combine together into a fairly complex infrastructure. So we see emergence of this, and we actually see acceleration of this. Now you have MuleSoft and other types of new generation type of middleware, and it kind of makes this space very interesting, exciting, and challenging. And it does require kind of a different look as to what does it mean to kind of, have this environment kind of work properly. So so that's kind of the overview. But you have kind of an emergence of all these types of new tech coming out.
It's interesting. You mentioned JMS. That is a blast from the past, and I'm sure for our
Yeah,
audience, some of them will be familiar with JMS. But it stands for Java Message Service, and it's still around. It's actually called the Jakarta Messaging API now, because Jakarta is sort of the new name for the open source Java effort. But it's still around and it's still API based. But one of the things that's interesting, you mentioned message queuing, MQ, you mentioned JMS, and you mentioned Kafka, and those are all asynchronous protocols or technologies. And so asynchrony is a key part of the story, but synchronous behavior is in many situations more familiar, right? The early web was fully synchronous, so HTTP began as a fully synchronous protocol, and still a lot of the interactions that we rely upon middleware for are synchronous, right? Request reply. We think of querying a database. We send it a SQL message and we get back a response. That's a synchronous interaction. So what is the story here, right, in terms of synchronous behavior in the mesh and asynchronous? Is the mesh fully asynchronous? Are you still dealing with synchronous behavior? So what's the story there?
I think actually, if you see most of the API-driven types of meshes, I would say a lot of them are synchronous. So that would be, let's say, RESTful calls. But there's also emergence of asynchronous even in that space, like WebSockets and stuff like that.
Mm-hmm.
And then when MQ kind of emerged, it kind of broke this whole asynchronous world. It introduced this asynchronous messaging where you put a message and you kind of go do your own thing. And then the message has a life of its own and then being consumed by a few other applications. And Kafka is asynchronous. And most of today's, I would say, modern messaging and integration platforms are kind of embraced, asynchronous world. But with that, obviously, it makes the application design somewhat simpler because you kind of fire and forget, but introduces a whole set of issues because now you have to be able to track and understand what is the life cycle of a message, and introduces a new concepts of, like, say, latency and lag. Because typically when you do asynchronous, you'll know you get a response back, or you didn't get a response back. You typically know there's an outage or there's a problem almost right there. In asynchronous world, it becomes a lot more complex. You send something and then it may or may not actually arrive to the destination. And the question is, how do you manage that problem?
Yeah, and this is an important distinction. You mentioned RESTful interactions, which are essentially based upon HTTP or the synchronous part of HTTP.
Right.
You mentioned WebSockets, and that's part of the HTTP protocol now, and that's asynchronous. But for many years, HTTP was fully synchronous, and that's sort of the behavior that we're sort of expecting. Although in the recent years, probably the last decade or so, even on web interfaces, we're expecting asynchronous behavior. Facebook pioneered this, right? You don't have to reload or click a link every time you want to see something new on Facebook. You just leave the page up and it'll update itself, right? And that is asynchronous behavior. But as you say, when you were talking about end-to-end communications, just waiting around for something to update in hopes that it will isn't typically good enough, right? We need some level of guarantees. Now, with synchronous behavior, we at least have a guarantee, right? We're waiting until we get the response, and if we don't get the response, then we know there's a problem and we can deal with it right away. With asynchronous behavior, it's a lot more fluid, right? The response might be sooner, it might be later, and if we have a lot of these going on, it can be really hard to track down. And that sort of brings us to the observability question. So, how do we go about keeping track of an environment with a lot of messages, some asynchronous, some synchronous, where things could go wrong anywhere, right? What's the approach?
So I think it's really, there's layers of observability. So on one end, you have to make sure that the infrastructure is up and running and it's doing what it's supposed to do. And a lot of observability today is focused around infrastructure, right? VMs, memory, CPU, applications, their availability and performance and things like that. Memory, disk utilization, and stuff like that. But integration introduces the whole new layer of kind of issues. Not only you have to pay attention to the infrastructure itself, but you also have to pay attention to traffic. I compare it to almost like a highway system. I mean, we're all familiar, drive down the highway and you have bottlenecks developing. And the question is, well, how do you predict? First of all, how do you detect those bottlenecks? But the more important, how can you predict those bottlenecks? A common problem obviously arises. Let's say we all paid people and we all, bought, let's say, stocks. I mean, you submit a trade and it completes. But what happens if you submit a trade and it just doesn't complete? I mean, that's a problem you're going to call a bank. And somebody is responsible within that organization of tracking the life cycle of these messages. So now you look at the layers of observability. Not only you have to look at what's happening in the infrastructure itself, but you actually have to be precise and measure what's happening in the message flows. What routes is the message taking? Are there bottlenecks? Are there latencies? Is there something developing in the message traffic flow? And then do you have enough capacity, and are you able to provide enough remediation before the problems occur? Because, think of it as also traffic. Once there's a bottleneck, it's pretty complicated to actually untangle the mess. So you want to be in a position where you actually never get to that problem. So that's how I would say there's really layers of multiple things that you have to do in the mesh in order to ensure proper service delivery.
Yeah, so I think there's two important things that are going on here, and what you're talking about sort of fits in between them, two familiar areas that sort of help provide some contrast to the problems you're addressing. On the one hand, when we talk about observability, we're usually talking about telemetry coming from systems or applications or virtual machines, sometimes containers or pods, but they're the things, not the message infrastructure connecting the things, right? So observability usually doesn't focus on the messaging part of the story.
Right.
So that's an interesting angle. The other part of the story is that for organizations who are thinking about how messages get from one place to another, they usually think of that as a network problem with a network solution. And clearly there has to be a network there. If you don't have the network, then you're not going to get messages to their destination. But all of the network operations or NetOps capabilities will keep track of the packets and how they're flowing. But that's at layers 3 and 4, in the middle of the OSI stack. Messages, though, operate typically at layer 7, the content level, right? You have to assemble the packets into a message before you can deal with it as a message. So you're not looking at the packets per se, or you're not providing observability into the packets. You're providing observability into the messaging infrastructure, which could be messages or could be other types of information flow, requests or other things. So that's sort of a different kind of observability, and it's typically falls through the cracks. What do you see as being the challenges there? I mean, you have observability story, but it's not traditional observability and it's not network observability. So what are the challenges with that?
Well, the challenges with that, the sheer amount of traffic. I mean, if you look at the organization, I mean, you have X number of applications, let's say even large organizations, thousands of applications, and they collect, hundreds of thousands of metrics. Once we get into the messaging, we're talking about millions, billions, like some of the organizations that we talked to. 200 billion messages a month. So the sheer volume of exchange is just enormous. And then the question is, how do you deal with that? How do you untangle this mess and figure out where the problems are? Well, and that's, I think, the big challenge. And there's different approaches to that. Obviously, one is, track every single message. The other one is, being more kind of figure out where your most important traffic pathways are and try to focus on those. Obviously monitor things like latency, where the bottlenecks are. And this is where machine learning and AI really helps a lot, because, you don't have to actually look at latency and say, hey, we got a problem. That's already too late because traffic's coming in and, you're most likely going to have to deal with a crisis situation. So looking at predictive or looking at certain key indicators and figuring out what might happen in the future so you can kind of tackle it. But essentially, it's looking at important traffic and figuring out how it moves and figuring out how it can potentially move in the future so you can tackle it early on. That's why I would say it's really a combination of machine learning, AI, and algorithms to figure out how the pathways are flowing, and then have proactive ways to deal with this. But then there's another angle to messages. There's messages that you track and figure out how the flows are, but then what happens with messages that are actually at rest? You have to be able to actually take action on these messages. Like, for example, you have $1 million transaction or a payment and it's stuck somewhere. Well, knowing that it's too late or it's lagging is not good enough anymore, because you have to be able to go in and potentially reroute the traffic. It's like moving cars from one exit from one highway to another. You have to be able to do that. So it presents a whole set of challenges there. But there are ways to tackle it.
Right. So that rerouting of traffic, that's a good metaphor because we've all been in traffic, and if there's a blockage ahead, either that will stop traffic for miles and might take hours to clear up, or you have to reroute the traffic on a detour, and then at least traffic will keep moving.
Right.
But that's more than just observability, right? We can have traffic cameras, and they will tell us there's an accident that's blocking traffic, but the cameras aren't going to solve the problem. They just send an alert to somebody who's now supposed to show up and solve the problem. So there's more to the problem than observability, but without the observability, the police aren't even going to know there's an accident,
Exactly.
right? So there's two sides of the same two sides of the same coin. You need both the observability and the essentially real-time response, real-time mitigation in order to keep the traffic flowing. And so you also mentioned a moment ago Kafka, which is a scalable, asynchronous, open source technology, and Kafka is both a plus and a minus, right? For organizations that use it, it provides this great scalable asynchronous infrastructure, but it also has its own issues in terms of how it's managed and dealt with. So a lot of organizations are essentially finding workarounds to keep Kafka from being the problem, and it can be a complex situation, right? You might say, well, Kafka is just a magic wand and everything will move swimmingly, but that's not generally the reality. So organizations end up implementing multiple protocols, whether it's Kafka plus other types of asynchronous technologies, or Kafka combined with REST. So you have this asynchronous backend and a more synchronous front end. So to support the user interfaces, you might want a more synchronous behavior, but there's Kafka behind the scenes, and that can also introduce problems because of the relative, the difference behavior, sort of an impedance mismatch between,
Right.
REST and Kafka or other streaming protocols. So, what sort of problems have you run into in terms of synchronous and asynchronous together, or other problems? It'd be good to sort of drill down into some of the
Right.
issues you've seen.
So they kind of compound each other, right? So the biggest thing that we see is latency, and how do you
Mhm.
deal with latency? And the latency shows up in different ways, and um, and obviously, if you're combining synchronous with asynchronous, where the asynchronous infrastructure is actually introduces a whole bunch of latency, then that latency shows up in a synchronous communication as well.
Mhm.
A simple use case: you make a RESTful call that in itself application puts a message on the topic, and let's say you have a 10-second latency. Well, the RESTful call could potentially see a 10-second or more response rate. So now you have a layer that supposedly should provide that level of asynchronous communication, but it's still to the end user. Asynchronous actually sees a very synchronous and actually sees the whole latency exposed to the synchronous call. So therefore, latency is one of the biggest issues, right? You have to be able to kind of figure out in all of these topics, because you have producers and consumers publishing at different rates. You have constantly things like you have to measure things like backlog and how much traffic is coming in versus coming out, and you have to do it all in real time and figuring out where your lags are. And then you have to look at, well, how they're progressing over time. Are they improving, or are they going down, or are they going up? And therefore, you have to be able to respond to these types of things. So latency I would say, is one of the biggest issues. And the other thing is simply because these new clustered type of messaging platforms, because now you have multiple brokers, multiple, thousands of consumers and producers. It's kind of like, okay, well, where's the latency? Where's it has an opportunity to develop? And then even if you know what the latency is, how do you know why there's a latency? Because it could be application, it could be a problem in the application, it could be network, it could be IO. So it could be so many things. It could be even like we've seen so many times, because Kafka is Java. It could be just that the JVM is not configured properly, and you're just hitting the resources on the heap and garbage collection. So there's just a whole set of other things that you have to consider, but it shows up in this metric, lag. So now that you know, and observability could tell you that you have lag, the bigger problem becomes is, why do you have lag, and where do you need to do to figure it out? And that's I think is where people spend, probably 90 or 80% of the time, is trying to figure out, why do I have lag? And that's a kind of another topic. You get into a war room and try to figure out what's going on.
But that really is a core to the topic, right? That war room problem, because lag could have different causes that are within the realm of different people's,
Correct.
challenges, right? So you might have the network people, it might be the database people, it would be the Kafka people or other pieces of middleware, the front end people dealing with the web server, and there's some sort of lag, and now everybody doesn't know what the problem is, and they're all looking at different information, right? Web server logs are telling you one thing, right? The database logs are telling you another, and then you might have some traditional observability tool telling you about the backend service or a container or something like that, containers and pods in Kubernetes or something, and they'll give you visibility into that. But now you have this problem that people are bringing to the table different kinds of information, different kinds of telemetry, and now they have to make sense of it. And it's a real-time problem, right? The cars are being backed up on the freeway. We want to take care of it right away. So this is also part of the observability challenge, is how do we provide visibility into the different possible things, even though they're not all necessarily Kubernetes or database or Kafka or the front end technology, and that's a huge part of the story. And we've all been there, right? With LinkedIn, you working on LinkedIn, and LinkedIn is an asynchronous interface, right? It'll sort of build as it goes, but then you'll get the something went wrong screen, right? The LinkedIn fail whale, and
Oops.
what's happening is something on the front end times out because something on the back end is taking too long, and that's that latency problem. When latency on the back end runs into a synchronous front end, or just a front end that is expecting a certain response time, you'll get timeouts, which means the entire transaction fails, right? And you have to start over, which is one thing if you're just hit reload on LinkedIn. It's quite another if you're sending money via money transfer, where it's millions of dollars at stake. It's a very different kind of thing. So that's definitely definitely a part of the challenge. So
and that's where the algos come in. I mean, so, and I think that's where the explosion of AI ML is really helpful, right? Because its reality is the problem is so complex, not one expert really knows what's going on. I mean, how many people can you ask within the organization, say, do you know all of the possible ways and interconnections that are happening in the environment? I would venture to say this is going to be almost nobody that truly understands how the system really works. So this is where the help of algos comes in, and where you start building correlations, and maybe not a causation. Causation is a much more difficult root cause. I would say a probable cause, or a probable set of suspects that you need to pay attention to. That helps a lot, because think about this: out of 100 possibilities, if I can narrow you down to 2 or 3, I've just cut down 98% of the work. So even that is helpful. So I think that's where the algorithms and ML can help with building out correlations and different models that, with machine learning, to try to figure out what are the relevant set of attributes that you should be paying attention versus attributes that might potentially have no relationship to the problem at stake. And I think that's where the ML and AI have its place.
Yeah, machine learning. I mean, AI and machine learning have been in the news lately with ChatGPT and generative AI. But what we're talking about here is really a different approach, where you're looking at historical data about the behavior of these complex systems, and the machine learning is able to essentially distill lessons from historical behavior and recognize patterns in the current or real-time behavior, and say that's similar to something that's happened before, and so here's what a likely scenario is. And that works very well when we have systems that behave in similar patterns. It's not like everything is different every time, right? There's similar patterns to how systems behave, how systems fail, right? Traffic, an accident causes a bottleneck, and if there's a bottleneck up ahead, you figure it's either an accident or construction, right? There's really no other, right? You sort of having a sense as to what the problems are, and that sense gives the machine learning something to work with. So that can be a very straightforward way of identifying anomalous behavior and possible causes of problems. And in fact, it's focused on anomalies, right? Differences in behavior from what would be normal. And as a result, machine learning can often catch problems as they're brewing, right? Even before something fails, right? They can identify something anomalous that will say, well, there's a problem brewing. A simple example would be, some system is having a near out of memory situation. So obviously you want to catch that before it goes out of memory. But there can be much more complex kinds of scenarios where you can catch something early in a complex integration, right?
Exactly. However, even in that area, the question becomes is what do you even measure? So part of the observability challenge, I would say, is not just, okay, well, here's the things and you can measure flow. But the problem is there's just so many metrics. And one of the problems is, well, what do you even measure? Like, what are the things that actually matter? Today, what I see a lot of kind of organizations do is do kind of a brute force approach. And that is, let's collect everything and let's throw kind of machine learning algos on top of it. I guess it's a problem that you could solve, but the issue is very expensive. Think about collecting every message, every metric about every single device. I mean, you're talking about, I don't know, petabytes. I mean, this is why you have, log analytics and all those other tools. They simply gather up so much data, and it's just very, very expensive approach. The other way is to actually figure out what's important. And that's where I think algos can help as well. Looking at the metrics that you're collecting, actually figuring out, well, out of the problems that are happening and out of the things that we try to figure out based on the problem resolution, what is actually, what you should be collecting. And I don't see enough platforms actually make this type of recommendation, saying, look at this, set of things. Well, this is the thing actually you should be focusing on versus, hey, here's the root cause or probable cause. And that's another area I think observability platforms need to kind of pay attention to.
Yeah, and that's a challenge. It's only going to get worse, right? The more sources of telemetry we have, the more we'll be scratching our heads wondering which ones we should pay attention to. And if we make the wrong choice, then it doesn't matter how good our technology is, we'll miss the causes of problems. So we only have a few minutes left. I wanted to bring us back to the notion of a mesh and that H at the end, which stands for hybrid cloud. In the early days of middleware, it was all on premises. I remember the enterprise service buses of the mid 2000s. That was all on premises technology, and it was pretty straightforward. Where the things were that you were trying to integrate. Now we have a hybrid cloud scenario where some of it's on-prem, some in one cloud, some in another, and sometimes the middleware or the messaging infrastructure is provided by the cloud providers. You may have limited visibility into that, but in any case, you're connecting that to stuff outside of one cloud, connecting it to an on-prem system or whatever it is. So what are some of the challenges that the hybrid cloud environment, just our sort of our modern and hybrid environment, brings to the table that we may not have already discussed, that might be more of an on-premises challenge?
Right. Yeah, it's a good point. I mean, it is a significant challenge. We see more and more organizations do that. And let's say they would have MQ in the backend connecting to the mainframes, but then Kafka and others in the cloud, and then it's all connected via APIs and gateways. It just makes the problem a lot more complex. So one problem is now you don't have control over this environment. So you have control. So you lose control. Let's say it's AWS or Azure. So that's another. Now you have also heterogeneous tools. So you've got a set of tools to manage your cloud environment and a completely different set of tools to manage your on-prem environment. So now you've got that complexity. There's different flavors also. So for example, Kafka flavors on AWS different from, let's say, on-prem, and an open source Kafka. So it just creates a whole set of complexities of multiple layers. One is simply interconnecting and how do you observe this environment. The other is how do you manage this whole environment in a kind of I would say, risk efficient way, because for a lot of organizations, it may open up new opportunities, but it also introduces a whole range of risks, right? So for example, you could be hacked. And then what happens? What kind of information do you actually even send across the cloud? So that becomes a consideration in the kind of hybrid environment versus on-prem. You have control over these assets. And obviously latency, you don't control things that are happening over the internet. So you might be thinking, on your, within the on-prem, you have control, you have your routers and network, you can control pretty well. But then what happens outside, you don't have as much control over that. So that requires obviously a consolidated, a more holistic approach.
Very good. Well, I think we're at the half-hour mark, so we should probably open it up to questions. So, Jessica, I think you're picking the questions for us. So, do we have any questions that we can get started on?
Thank you, Jason and Albert. We will now open up the floor for a Q&A. I received some questions sent directly to me, and you can also send your questions in the chat box as well, and I will read them out loud. So the first question I have is for Albert. In working with your current clients, what are some common challenges with observability for this integration mesh that organizations are dealing with today?
So when we work with our customers, typically observability challenges actually go beyond observability, and partly because it's also a human problem, and because how do you work with such a complex environment? So on one side, monitoring and observability is one part of the equation, but the other part of this is what do you do once there's a problem? And then you need a whole set of tools and processes built on top of it to figure out, okay, we have a traffic or backlog and latency. Okay, what tools do you bring in to actually solve these problems? For example, things like message management, configuration management, because a lot of times you have to change things, you have to reconfigure things, you have to reroute things. So we typically look at it as a holistic problem. I call it, observability plus, meaning you observe things, but then what do you do after? So you have to have all kinds of tools to be able to now remedy the problem, fix the problem, maybe change configurations or deploy new topologies potentially. And then even in some situations, reroute traffic. And we've seen environments where it is actually was a lifesaver. You have a bunch of messages of payment stuck in one place and you can't remedy the problem, but you have to reroute the traffic. So you got to be able to do that. And then there's a whole set of developers, meaning in today, meshes are powering and all kinds of people, right? Because it's a almost shared infrastructure. So you have obviously administrators, ops, but then you have developers, and then developers want to be able to come in and do things on their, assets, their topics, on their specific queues. So a lot of it is also providing visibility and tools to people who are actually using the mesh on a day-to-day basis.
The next question I received is, do you think configuration management is part of observability?
So technically, in today's, if you look at, I would say, if we look at probably analyst definition of observability, they would probably say it's not. I would say it is. And the reason is because you cannot do certain things in observability without doing configuration management, especially in today's world where a lot of things are automated. So you got to build configuration management into the CI/CD. So the whole thing is kind of linked together. I think the world of silos is going away. Yes, you have certain disciplines like application performance monitoring and log analytics, but today it's really all connected. So while observability maybe focuses on one specific, I would say, problem domain, I think for most people, especially dealing with complex problems today, it's really a cross-section of all of these that needs to be connected together. So I would say, yes, you could observe, but if you can't do anything about it, why even observe? So I can make a case where a lot of the automation and actions and things like that should really be part of observability.
Yeah, Al, I think that's spot on. I mean, with you have observability without configuration management is sort of dumb observability, right? You pre-configure what you're looking at and you get telemetry from those things. But as we talked about a moment ago, there are more and more things we could be looking at, and we need to be smarter about what we're looking at, what we're paying attention to of all the information that we have. And part of that is a configuration challenge, right? We want to configure our observability systems, our observability tools to help us pay attention to the right things. And then there's the other side of the story is being able to observe our configurations, right? So configurations of our infrastructure are inherently dynamic in today's modern cloud native world. So we need to observe the configurations. And in many cases, that is often the most important thing to observe, right, is to observe how we've configured things versus the underlying technology. This is especially important in the clouds, in public clouds, where the underlying technology is hidden from view anyway, right? The cloud providers aren't telling you about their physical network. So what do you observe? Well, you can observe how you've configured your cloud assets. And so there's a two-way side here, two-way story here, right? We have to observe our configurations. We also have to properly configure our observability. So they really do go hand in hand.
Yeah, good point.
Another question just came in. How do you see vendors like you leverage something like ChatGPT to add value to their users?
That's a good question. So here's interesting. So ChatGPT allows, obviously it hooks into the, think of it as the world knowledge in a sense, right? You can ask it all kinds of questions, it'll produce you, even write code. I mean, I logged into ChatGPT, I said, write me a Java code. And it actually wrote me nice little routine in a few seconds. So, but what's interesting is you can now take the data sets that you're collecting about whatever it is and feed it to ChatGPT, and it can learn on top of those data sets. And obviously, those are proprietary data sets, private data sets. So imagine an organization harvesting its data, whether that's logs, whether that's metrics, or whatever, feeding into this language model, and now being able to ask very relevant and intelligent questions about its infrastructure. Maybe it's even about its future and about its performance, or even how to optimize it. So today we ask these usually experts. We say, well, how do you do this and how do you do that? Well, now you have this whole new way to ask questions and get answers from data that's being collected directly from your environment that nobody has access to. So if you just hook into ChatGPT today, it's not going to know anything about the problem domain that you're talking about unless it's in public knowledge. But now there's a way to do that. So I think AI ops and this whole ops area is going to be, disrupted probably in very interesting ways by connecting these private data sources into this language model.
Yeah, it's important to remember that ChatGPT and the broader generative technologies are designed to be believable, but not designed to be truthful. This is one of the problems with the publicly available ChatGPT is you can ask it things and it'll give you a believable answer, and then you look closely and it's like, well, it's just making stuff up out of the blue, right? It may not be accurate at all. And you can even trip it up and have it tell you that 2 + 2 = 5, and you can't convince it that 2 + 2 = 5 by just repeating 2 + 2 = 5 to it a few times, and it will just start believing that, right? So in the context of enterprise IT, as Al mentioned, it's really a question of feeding the language model the right information, right? If you feed it accurate telemetry, right, you're not giving it nonsense, you're giving it accurate core information, then it is more likely to generate truthful results. But still, that's not really what a language model is designed to do. It just happens that if you feed it good information, then you'll get good information out, but it's not guaranteed, right? So it should always be taken with a grain of salt. So there's a value is that you have this natural language result that is now easy for anybody to understand, and it is believable, but you always have to go back and double check because it's still is perfectly happy to make stuff up, fill in the gaps between the core data it's being fed in order to come up with a reasonable conclusion that may not be accurate. So this is one of the challenges. We're sort of in this believability paradox with ChatGPT, that it's so believable that people seem to assume that it is telling you the truth, but you don't want to make that assumption.
Right. Although it's interesting with this whole AI is there's evolution. So there's different versions of ChatGPT in the OpenAI. There's GPT 3, 3.5, and there's the new one just was announced 4. I think as this technology evolves, I think this problem is going to be tackled in some way. I think we're just in the very beginning, but the promise of it in the sense that it could ask a lot of these, once they solve this problem. And I agree with you. Sometimes it says things that are, out of this world. But I would say as this evolves, it's going to get better and better and better, and it's going to create some interesting disruptions in this space.
Yeah, I definitely agree.
All right, next question. Would tracking messages and transactions introduce a significant performance overhead? And if so, what are the best ways to deal with it?
Well, like everything else, measurement usually does, any kind of measurement. So there's usually a price to pay. Even if you measure like things like CPU memory, there is a price to pay. It's a question is the price to pay worth the benefit? And in some cases it does. Like, for example, if you're just looking at, non-mission critical environment and message loss doesn't really matter, then maybe it's not important to track messages in this particular case. But then let's take an example of a bank or a financial institution. and they're doing payments or wire transfers, then in that case, it does make a difference to track each and every payment, because each and every payment is important. So I think it needs to look at the context of, do you need to track everything? No. I think it's a question of, where does it make sense to track? And the way I look at it, when you have a high value types of transactions and messages, then I think it does make sense, and it's worth paying the price. Now, and then the other question usually people ask, well, what happens if I miss? Well, then the question is, what's the outcome? Well, if the outcome is nothing, then don't track the messages. But if the outcome is my customers will leave, I'm going to have impact on my customer experience significant, I have impact on my revenue or penalties of some sort, then it does make sense. So I think it needs to be put in the context of, what's the problem, how mission critical something is, and in that case, it makes sense. But there are other approaches, like, for example, you can not necessarily track every single message, but you can track or pay attention to lag across different topics and queues. And therefore, it gives you an indication of a buildup, but you don't have to track necessarily every message. So there are approaches of different layers of observability. Each one has its own pros and cons. And I think in some cases, it does make sense to track every message, as I pointed out, in mission critical environments where messages are high value.
Yeah, another consideration is the role that message level observability plays in cybersecurity, right? For the cybersecurity perspective, the challenge might be to identify malicious content in messages or malicious messages, right? Whether it's a malware or something in a message. And the hacker is going to try to make those messages look as benign as possible. So they're not going to look like the mission critical messages that everybody expects to pay close attention to. They're going to look like messages that people are likely going to ignore, because then the attacker is going to have more luck with their attack, right? So there's other reasons to leverage this kind of technology, especially in the cybersecurity arena, where you're looking for different kinds of problems. You're not necessarily looking for bottlenecks. You're looking for malicious behavior, and it's a whole different set of patterns to look for.
Well, thank you everyone for attending. We truly appreciate your time. We will have this Tech Talk available on demand, posted on the Meshiq website following this call at www.meshiq.com. Also, please note, this webinar is part of a series of Tech Talks. We rotate the topics and really try to focus on different middleware technologies. We would love to have you join again, so please be on the lookout for our next upcoming webinar on April 18th at 11 a.m. Eastern Time. The next topic will focus on IBM MQ, and we will be partnering with Texas MQ on this webinar, and Richard Nikula will be presenting. He is Meshiq's VP of Product Development and Support. We hope you can join, and we'll be excited to see you there. So thank you, Jason and Albert, again for speaking today, and thank you everyone for attending our webinar today. Have a great rest of your day.